So, day 5, Friday, January 26th, Unit 9, Worksheet 5. We are going to put together, kind of like yesterday, we put together things that we sort of already knew. Today with inequalities, we're going to solve trig equations and then use those to solve inequalities. But inequalities, do you remember how we did inequalities before? How we've done inequalities before? Okay, yeah, it's that greater than or equal to stuff. How did we solve them, or what did we do? What was part of the process? Do you remember any of it? Well, then a brief recap. We will find the zeros. That's what we did yesterday, so that part sort of continues on today. We'll find the zeros. And then here's the inequality part. We'll put them on a number line. And then we'll test the intervals. Find the zeros, put them on a number line, test the intervals. So find the zeros, we did that yesterday with trig functions. Number line, test intervals, we've done that a while back. So today we're going to put it together. And so it's another day where there's no new concepts. It's just let's jump in and work some problems. Okay, let's do number 1. We're going to omit number 3, and I'll tell you why when we get there. Let f be the function defined by 2 sine squared x minus 1. What are the intervals on 0 to 2 pi when the graph of f is below the x-axis? Well, below the x-axis, that's just a fancy way of saying this thing is less than 0. Right, that's just a vocabulary kind of thing. So sine squared of x is, you know what, let's slow it down a little bit. Let's find the 0 first. I'm going to set it equal to 0, not worry about the inequality thing, and then I'll put them on a number line, and that's when I'll worry about whether I'm less than or greater than or 0. So sine squared of x is 1/2, which means sine of x is equal to plus or minus. I'm going to go ahead and kind of fix it on the fly here. Plus or minus root 2 over 2. Alright, so those are my, oops, not done yet. Sines root 2 over 2. That's the middle angles. And the pluses and minuses, it's all of them. So the positive ones are up and the negative ones are down, but we want all of them. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's where we ended the lesson yesterday. We stopped there, we got our zeros. But today we want to know where it's less than 0. So we'll put those on a number line. Our number line is restricted from 0 to 2 pi. So can't go past 0 or 2 pi. And then pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And your number line does not need to be to scale, so you don't have to worry about, well, exactly, I mean, they better be in order, but it doesn't have to be to scale. Open circles or closed circles for those? Open, because of the equal sign, or the not equal sign not being there. And then I just need to check an interval and alternate. So what would you like to plug in? To me, I see an obvious choice for this one, but I think I'd pick pi. But you could pick pi over 2, or you could get crazy and pick 7 pi over 6, as long as you can figure out where it goes. but I think pi would be the best choice. So let's check pi into our original inequality here. 2 sine of pi squared minus 1, like less than or equal to 0? Question mark? Because we don't know yet. That's what we're trying to check. Maybe this seems obvious, but as far as checking, if you pick one of the quadrant angles, the quadrantals is the fancy name for that, then your sine or cosines will be 0s and 1s, and it just makes life a little easier. Right? If you end up picking pi over 4 or pi over 6, then you got root 2 over 2 and root 3 over 2, and it just makes the math a little harder. Okay, sine of pi, that is 0. So 0 minus 1 is negative 1. That is less than 0. So we will shade there. That's a check. That's a yes. And then we alternate off of that. So that's a no, and that's a yes. That's a no, and that's a yes. You don't really need to shade and do checks and X's, but that's up to you. Okay, that's not an official answer because I need to give it in a more formal looking. So let's do interval notation. So 0 to pi over 4, but right away, like, I definitely don't want to include pi over 4. But what about 0? Do you think we include it or not? See some yeses and some no's. Okay, so we can definitely include it from this. This doesn't exclude it. And there's no reason to exclude it any other, because if we kept going with our number line, then this would continue until wherever we got to our next 0 is. We don't care about it, but we don't get there. So yeah, we can include 0. So we'll include our endpoints on this one. So 0 to pi over 4, 3 pi over 4 to 5 pi over 4, and 7 pi over 4 to 2 pi. Squeeze it in there. So long problem, lots going on, but lots of stuff we've already done going on. Solve a trig equation, put it on a number line, test the intervals.
So was that same type of problem, but at the top it didn't have the equal to? Would you include it or not?
Like up here?
Yeah.
Yeah, then you could not include it. Like from the get-go, you wouldn't be able to include it if that didn't have the equal to there. That would be kind of tricky. We don't usually do that kind of thing. But yeah, you should be paying attention to those. Number 2, determine the intervals on 0 to 2 pi that satisfy sine of 2x minus cosine of x. And I'm just going to go ahead and change it to equal 0. And then we'll worry about the inequality stuff later. Okay, sine of 2x. We already hit one of these. That's 2 sine x cosine x minus cosine x equals 0. Factor out the cosine of x. 2 sine of x minus 1 equals 0. So cosine of x equals 0. Sine of x equals 1/2. Again, I always draw the unit circle when I'm solving these. Maybe you don't have to. Cosine is 0 there and there. Pi over 2 and 3 pi over 2. Sine of x is 1/2. Let's see on the up quadrants. I'm going to try to challenge myself and not draw the unit circle. That's at the over 6's, so that would be pi over 6 and 5 pi over 6. And even though I didn't draw them, I visualized it, so that doesn't really count as not drawing the picture. Okay, so number line with those things on it from 0 to 2 pi. And again, your number line doesn't have to be perfect, but it definitely has to be in order. Like, yeah, it's quite humorous when people put this on out of order. It's like, come on, you can't order some fractions here. So out of all those, which one's the smallest? Now everyone's nervous. Pi over 6. And then pi over 2. And then 5 pi over 6. And then 3 pi over 2. And my picture is definitely not to scale, but again, it doesn't have to be to scale. It's just about putting them on in order. Okay, what would you like to check? I think pi again. Now, here's where my number line not being to scale might be tricky, because pi is right between 0 and 2 pi, but I better be careful if it's not right there on my number line, right? It's got to be right here. There's where pi is. So yeah, my scale is a little bit messed up, but again, it doesn't matter as long as you got everything in order. So let's check x equals pi. Usually best to just go all the way back to the beginning. Check it in the original. So sine of 2 pi minus cosine of pi greater than or equal to 0. And that's a question mark. That's not a statement yet. That's what we're testing. Sine of 2 pi is 0. Cosine of pi is negative 1. 1 is greater than or 0. Yes, that is a true statement. Oh, I skipped a step. What do I need to do? What do I need to think about? Yeah, close circles. Oops, not at 2 pi. 2 pi is not a solution. That's just the end of the number line. So that one works, which means that one doesn't. That one doesn't. That one does. So pi over 6 to pi over 2. And then 5 pi over 6 to 3 pi over 2. Why am I not checking all the intervals? What allows me to do that? Well, I'm alternating. When can I not alternate? I guess that's when there's a double root. Okay, the reason we're going to skip number 3 is because there's no double roots, but it doesn't alternate. What? We don't want to deal with that. You want to play with it and figure out why? Knock yourself out. We're going to skip that one because we could solve it, but we'd have to check every interval. And for that one, there's 4 solutions. No, there's 3 solutions, so 4 intervals. We just don't want to do that. We want to be able to use our shortcut. So we will skip number 3. Number 4. Okay, this is not inequalities anymore. This is something new, something different. We have not done this before. Let W be the function defined as 2 sine 2x. So that 2 in there. Now we've handled that before with just replacing sine 2x with a trig identity, 2 sine x cosine x. But that's not going to help us here because we're setting this thing equal to 1. So 2 sine 2x equals 1. So if I replace sine of 2x with 2 sine x cosine x, it doesn't do me any good. So let's keep working with the 2x in there. Sine of 2x equals a half. Let's see. So where does the sine equal a half? It would be in the up quadrants. pi over 6 and 5 pi over 6. Here's where things get a little bit strange, though. So I need the argument to be pi over 6. I want to be taking the sign of pi over 6. So what do I need to say equals pi over 6 and 5 pi over 6? 2x needs to be pi over 6 and 5 pi over 6. Because I want to take the sign of pi over 6, so I need 2x to be pi over 6. Now there's another trick going on. X is between 0 and 2 pi. Alright, so we looked at that. But this question is about 2x. So what do you think 2x needs to be between? Like, what could I do to this inequality to get to this inequality? If I multiply everybody by 2, then I want 2x to be between 0 and 4 pi. So back to my picture over here, those answers are right, but now that I'm allowed to go to 4 pi, that means I can go all the way around and then some. So what is that? All the way around is 2 pi plus another pi over 6. That would be 13 pi over 6. 2 pi around plus another 5 pi over 6 would be 17 pi over 6. And then now we can do what you probably wanted to do a couple minutes ago, divide by 2, or maybe even better, multiply by a half. So that just changes all our denominators to 12s. So we went past 2 pi, but then when we divided, that brought our answers back onto that interval that we were wanting. Then you can check and see 17 over 12 is less than 2, so we're good with those answers. So the multiplier in there kind of expands our options, and then we divide, and it shrinks them back to the original interval. Yeah, let's do another one of those. Number 5, what are all the values of x between 0 and 2 pi that satisfy this equation? So tangent squared of 2x equals 3, which means the tangent of 2x equals plus or minus the square root of 3. Let's see, the tangent's the square root of 3 at the pi over 3, so that's the tangent 3 trick. And plus or minus means I'm not really worried about which quadrant, it's all of the steep angles. So pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. But what needs to equal pi over 3 and 2 pi over 3 and 4 pi over 3 and 5 pi over 3? 2x. Which means, wait a minute, I need to look more than 0 to 2 pi. I want to look between 0 and 4 pi. So once again, I need to go around the circle again. So all the way around, that's 2 pi. And then I go each of those more. Another way to say that is you take your original answers, and I'm going to add 2 pi to them to come up with sort of my second set of answers. 2 pi is 6 over 3 if I get a common denominator. So 7 over 3, 8 over 3, 10 over 3, and 11 over 3. So I got 8 answers. Because I got to go 2 times around. Okay, people start to get confused because like 11 over 3, that's bigger than 2. Well, yes, but when I divide by 2 to get x by itself, then these will all shrink back to the interval that I want. So let's multiply everybody by a half. I'm going to, some will reduce, but man, it's so easy to just to change all the denominators to 6, so I'm going to do that first. Look, I know some will reduce, but slow and steady wins the race here. So multiply all the denominators by 2, and then I'll go in and reduce whoever can reduce. So that's an extra step that some of you would not show, and that's okay. Oof, that's a lot of answers. Sometimes you can start to get a feel for how many answers you will get, because let's just back all the way up. If tangent of x equals square root of 3, that would have 2 answers. But if we put a plus or minus on that, that would double the number of answers we have, so times 2. And if we put a 2x in the middle there, that would also double the number of answers we'd have. So usually 2 answers, but plus or minus means it doubles, and the 2x means it doubles. So I'm expecting 8 answers. 1, 2, 3, 4, 5, 6, 7, 8. You don't really need to do all that, but that's kind of an interesting side thing about what increases your number of answers. And if it makes sense to you, you can kind of get a check on your answers to see that you have the right amount. All right, last one. Oh, 2 things different about this one. What's different about this one? All right, it's a 3x, which means, I guess I'm going out of order over here. Oh, but my original is not 0 to 2 pi, so I will be looking 0 to 3 pi, and multiply everybody by 3. But that's a little bit out of order. I don't want to do that yet. 4 cosine squared 3x equals 3. Cosine squared 3x equals 3/4. Square root both sides. So cosine of 3x equals plus or minus root 3 over 2. Ugh. There's another one that's going to have a lot of answers because I got a plus or minus and I got a 3x. Let's see, cosine plus or minus root 3 over 2. That's the shallow angles. So all the over 6s. Pi over 6, 5 over 6, 7 over 6, 11 over 6, although I need to start being careful because that's what 3x equals. And 3x can go to 3 pi. So 3 pi is kind of weird. I'm going to label that spot as 3 pi. Odd, but that's not wrong. So I need to catch this spot. So that would be 13 pi over 6. And this spot would be 17 pi over 6. And I don't want the other two because I'm stopping at 3 pi. Stopping at 3 pi. So it's kind of weird that 2 of my angles get to get counted twice and 2 of them don't get to get counted twice because they were not the between 0 and 3 pi. Almost done. Multiply everybody by a third, which changes all my denominators to 18. Six answers, and they're all between 0 and pi, so you can kind of check to make sure that that's right. So I feel good about those. Alright, your assignment is worksheet 5, and now we've done everything that's going to be on the test. So Monday we'll review, Tuesday we'll review, and then block day we'll test. That's behind the video there. There we go. Monday review, Tuesday review, block day test. Friday is like, let me turn the video off so I don't